Well, hello 3C and welcome to some applications of exponential decay. So our goal for this video, I can create equations for exponential decay situations. Now exponential decay is actually very close to exponential growth, except that the numbers are getting smaller rather quickly rather than the numbers getting bigger rather quickly. So let's take a look at exponential decay. Exponential decay occurs when value is lost. Let me highlight that. Value is lost repeatedly. The general form of the equation looks the same, but the value we multiply by every time, that was the b, remember, b in the base, will be between 0 and 1. So that's important too. I'm going to take my handy highlighter and highlight that. When we multiply by the number between 0 and 1, our result is always smaller than what we started with. So let's have a quick look at this equation again. This is the same one we used for growth, where y represents the current value, a is what we started with, b is our growth factor, the thing that we're multiplying by every time, or in this case it's going to be not a growth factor so much as a decay factor, and the number of time periods is what our exponent is. So what have we got here? When we talk about something decaying in value, where x is given in terms of money, or not where the value is given in terms of money, the more common term we use is actually called depreciation. So if you see me say something about a computer or car depreciates at a certain rate, we know that depreciate means that the value is getting smaller. So example number 1, the decay rate is given as a percent. Electronics lose their value rather quickly since newer models are always coming out. It seems that as soon as you buy a new computer, it's already obsolete. So here's a situation where a MacBook Pro is purchased for $2,400 and it depreciates, there's that word I told you I was going to use, depreciates at a rate of 2% per month. Now that's important too. This is given to us in a monthly basis since it was purchased. Create an equation that models the value V of a MacBook Pro n months since its purchase date. Now, we know that since it's decaying that we have to have a B factor that's less than 1, so we're going to take 1 and subtract this rate. So there's a couple different ways that you can think about this. I'm going to do it straight up using this formula to start with. I'm going to take 1 and subtract this rate. Now 2% is 0.02, which means that it's 0.98 is our decay rate. The other thing that you can think about this is if it loses 2%, if it loses 2%, it keeps 98% because it always has to add to 100, right? So what we want our B to be is the part that we keep, so 0.98. So you can either change it to a decimal before you subtract from 1 or subtract it from 100 and then change your answer into a decimal. Now, as far as the equation goes, if I have value equals, now remember we have to take our initial price, which is 24,000, or sorry, 100, and in the first month it's going to keep 98% of its value. And then it's going to keep another 98% of its value and another 98% of its value every month, and we're going to let months be n. So there we go, where n stands for the number of months. What can you expect to sell the computer for when you upgrade to a new one, 3.5 years later? Well, remember that this n is in months. So we have to figure out how long we've had it in months. So there's 12 years in a month. So to figure out n, we take our 3.5 years we were given and times it by the 12 months in a year. Okay, so that's going to be 3.5 times 12 is, that's not it. 3.5 times 12 is 42. So we've got 42 months we're going to keep the computer, and we're going to see what other people will pay for it. So the value equals 2,400, 0.98, but now instead of this n, we're going to put in that 42 months that we're keeping the computer, and we want to know what it's worth after that 42 months. So let's plug it into the calculator. I'm going to do this part of it first when I plug it into the calculator. So I go 0.98 to the exponent, this button here, 42. Get my answer. Keep that on the calculator. Now I'm going to multiply by this 2400. So times 2400 equals 1,027 and 32 cents. 1,027 and 32 cents. And since this is a word problem, we should probably say, therefore, you can sell it for about $10.27. I'm not even going to put the cents down because this is just about, obviously. Next, nothing on, oh, is that it? Nope, there's one more. Here we go. Decay rate is given as a fraction or as a decimal. When you drink caffeine, it leaves your body according to an exponential rate of decay. It takes 4 hours to lose half the amount of caffeine in your system. We say that caffeine has a half-life of 4 hours. Okay, so this 4 hours is important, and it's called the half-life because it loses half the amount. So let's just think of what that means. Say we started with 10 milligrams of caffeine. 4 hours later, after 4 hours, that means we would have 5 milligrams. It loses half of its amount. After another 4 hours, well, some people will say, oh, well, then you have nothing because it loses its other half. No, not quite. It doesn't lose half of its initial amount. It loses half of this amount. So then it gets to be 2.5. After another 4 hours, we cut this in half again. So it's 1.25. Okay. So that's our exponential rate of decay. So now we're going to write an equation that models the percent of caffeine. Okay, so I'm going to use a big P for percent. And this is going to follow the same thing here. Let's write the general formula here. Y equals AB to the X. Okay. A is our initial amount. So if we're talking about percent, initially we have 100% of the caffeine that we drank. So I'm going to use 100. Now B is what we multiply by every time, and here's where that comes in. We have half every time. And that's what I did here. I split that in half to get 5, split that in half, split that in half. Away we go. I'm multiplying by half every time, or 0.5. And of course the N here, N is going to be the number of 4-hour intervals, because it is, or we can think of it as the number of half-lives in our little experiment. Okay, determine what percent of caffeine will be present in your system 20 hours after drinking the energy drink. So 20 hours later, how many half-lives have we gone through? Well, the easy thing here is we take N, we take our time period, and divide it by the half-life. Now the half-life is 4, so we could take 20 divided by 4, and we get 5. So this 20 was our time period, and this 4 is our half-life. So now we're going to plug it into here. Percent equals 100 times 0.5 to the, well, it was 5 half-lives, so it has to be to the 5th. And now I'm just going to take my handy-dandy calculator, and we're going to go 0.5 to the exponent 5. And now we're going to multiply by 100. So that's about 3% that's left. So after 20 hours, you'll have 3% of what you had drank before. And I believe that that is now the end of this lesson. See you later.